Alright, welcome to Chemistry Video 2.3, looking at derived units and density. Main objectives here are to perform density-related problems with the proper derived units. Just a reminder to turn off your cell phones, put down the social media, pause, rewind frequently while watching the video as needed, and to take some notes in the margins if you have any other questions. Let's go. So, derived units. Derived units are units made by combining the base units. So they're derived by combining base units. So like base units like grams and volume like centimeters cubed. So combining two units together is what a derived unit looks like. Couple examples now. So we got speed. Speed is on the next page here. Is meters per second. It's a very common speed. It's length time divided by time. Combine those two base units. And speed is how fast an object can move. Okay. Another one is volume. Okay, volume is defined as the space occupied by an object. And volume, as you may have remembered in some of your math classes, you can do a volume of a box like this, where you take the length, the width, and the height of it, and if you multiply those three dimensions together, you get the volume. Okay, and oftentimes because we'll use like centimeters or meters there. If you take all three of those lengths there, centimeters times centimeters times centimeters ends up being centimeters cubed, which is a very common unit. Over here on the right hand side we have like a cylinder here where you can use an equation like pi r squared times height. That's the area of the circle, and then times the height here helps you figure out the volume of that cylinder. So that's what volume is, the space an object occupies. Some important ones I want you to know are the milliliter, and that equals 1 centimeter cubed. So if you have a little box like this one right here, and imagine every single side is 1 centimeter. So if you have 1 centimeter by 1 centimeter by 1 centimeter, you end up with a volume of 1 centimeter cubed. That is the true definition of what a milliliter is. So like on our graduated cylinders that look like this, if you pour out a milliliter, it's the amount of liquid that would occupy a box that has 1 centimeter cubed for dimensions there. Okay. Another important one, not quite as commonly used though, is the liter. If you have a liter, that means you have 1,000 milliliters, and that's actually 1 decimeter cubed for its shape there. Okay. Basically, volume, you can measure the shape of regular solids like this one up here, and you can also measure the shape of another irregular shape like that one there. Solids are typically reported in centimeters cubed for their unit, cm cubed. Whereas liquids and gases will typically do in liters or milliliters. And we'll typically measure liquids then in objects like a graduated cylinder, which we call volumetrics. Okay. In your notes there it says explain and name the method for how you calculate the volume of an irregular shaped object. Well, we're going to use a method called volume displacement method. So that's in your notes there, volume displacement method. And I want you to write down some things here. So the first thing you would do in a situation like this is you would fill up a graduated cylinder, and you would read from the bottom of the meniscus, the bottom of the curve there, make a reading right there. And then, ooh, my page is off a little bit there. Oops, that's awkward. So that really should be inside the cylinder there. But basically, once you put your shape in, your object into the graduated cylinder, it would displace water and cause the water level to rise a little bit, and you would have another reading right here. And we would call this first one here the initial volume. And then you would take a second reading called the final volume. And the reason the water changed there is because of the object. So the volume of your object here is equal to the final volume right here, minus the initial volume right there. And that gives you what the shape, the volume of that shape is. We call it volume displacement. Okay. Another common derived unit in chemistry is density, which describes how much mass there is per unit volume. Okay. So you have this object, perhaps. Okay. It's got a volume, of course, but there's also a certain amount of mass inside of this thing here. And if you divide, and here's your equation you can write down on your sheet there. If you divide the mass by the volume, you end up with density, where d equals density, little m equals mass, capital V equals volume, and that's your density. Our two most common density units are the first one, which is for solids here, It's how many grams of mass there is per volume, cm cubed. And for liquids, we oftentimes will report it as grams per milliliter, like so. Those are probably the most common ways. They don't have to be those. I've seen things like kilograms per liter. I've seen just regular grams per liter. So all that matters, though, is that you have a mass divided by a density, or by a volume. A mass divided by a volume. That's what density is. In addition, density is kind of a cool thing because it can do a couple things. One, helps you identify unknown samples. Aluminum always has a density of around 2.7 grams per cm cubed. So if you experimentally determine that something has a density around that, there's a good chance it's aluminum. So we can use it for identification. And then also, density is a reason why things float or sink. When things float, it's because they're less dense than their surroundings. So that's why like a helium balloon floats, it's less dense than its surroundings. And the reason a rock sinks is because it's more dense than its surroundings, more dense than the water. So that's what density can do. So here we got a quick practice problem, number 2. Doing the math now. Now here's some things you need to do when you do the math problems for me. Circle what you're looking for, underline some information that's useful. So here we go. An object with a mass of, well, that's important, mass of this, raises the water level from 10.1 milliliters to 17.4 milliliters. What is the density? Okay, so we're looking for density, so we're looking for D equals question mark here. Here was a mass, so I'll put that M by that. And here it says the water level raises from 10.1 to 17.4. So this situation here is like the graduated cylinder that has water into it, which is up to 10.1 right here. And when you put our object into here now, the water is going to raise up to 17.4 milliliters. So if we do the difference between those two numbers, the final volume of 17.4 minus the original 10.1, that gives us a volume of 7.3. So the object we placed into this graduated cylinder caused the water to raise 7.3 milliliters, and that is the volume of the object. So that's our V we're looking for. So if you're solving for density, the density equation is D equals M over V. So just plug your numbers in now. So for mass on top, you plug in 2.34 grams, and please put your units in, divided by 7.3 milliliters, and this is equal to 0.321. And our unit, because they don't cancel each other here, that's our unit, grams per milliliter. So that's the density of the object in this particular problem. And by taking it one step farther here, will this particular object sink or float in water? Well, if things sink or float, we need to know the density of both objects. Water's density is 1 gram per centimeter cubed. So would this object sink or float compared to water's density? And the answer is it would float because it is less dense than water, so therefore it's going to sink, or sorry, it's going to float in water. Alright, that does it for derived units and density. Come ready to practice a little more on this. Good job.